So again, my name is Matt Laster. I'm a senior sales engineer here with ModelOp. ModelOp is a company focused on the upcoming market of model ops, not to be confused with MLOps. Model ops is generally seen as a superset of MLOps, right? So MLOps is focused on operationalization and governance and monitoring of machine learning models, AI, ML, TensorFlow this, PyTorch that kind of stuff. Whereas model ops is a broader, any type of model to be managed and governed kind of superset, if you will. So you'll find that a lot of banks typically already have pretty mature risk management processes and governance processes around their various models, same as in insurance companies. And that's where we ModelOp and where the ModelOps market is really thriving. So what I'm going to do today is spend the next probably 15, 30 minutes giving a quick dry run through the product, and then open it up for some questions and hands-on and labs and so forth. We do pretty typically do things like hosted trials and hosted evaluations. So if you do see something that's exciting or interesting, please reach out. Hop on our website, hop on pretty much anything, or Megan in chat can help coordinate next steps and so forth. Feel at this point I've left these two quotes on the screen long enough, so if you were going to read them, you probably have. And that's where, when we start talking about what is model operations, both in terms of AI ML for this audience, as well as in general, just all types of models. There's really three needs that we, as well as thought leaders, and then as well as all the analysts have started to identify, and that is the need for a robust inventory that allows me to see all of my models, regardless of platform, regardless of what factory I use to build them, regardless of workbench and runtime and language and libraries and so forth, as well as allows me to see the complete history of that model from, again, in the banking and MRM world, when I decided to build a model to solve my problem, how I built that model, who built that model, the documentation for that model, et cetera, all the way through to its approvals and pre-prod, path to production, and then post-production deployment, its ongoing monitoring and looking at things like stability indexes and data drift and concept drift and ethical bias and fairness and all of that kind of stuff. The second is really that same kind of thing, but more from an explainability and ethics perspective. So how do I make sure that my models are good? Not good in the sense of accurate, but good in the sense of accurate and they make sense and they are ethical and there's no inherent bias. Hopefully by now everyone has seen the documentary on Netflix, Inherent Bias or Coded Bias, as well as some of the others, exposés that have been done. A lot of great content there, but it's a very real issue. And then, the third piece or need really is around risk control, and being able to understand and ultimately minimize, but identify and react to when our models start to degrade outside of and below thresholds. So when does a model, when is its retraining, when is its original training data set so inaccurate or so different from its normal everyday data that you're experiencing things like data drift or model concept drift and those types of things, and being able to not only identify but ultimately react. When you combine those three things, and those same three things are really what ModelOps Center, the platform we provide, is all about. So it is a production model inventory. It is a monitoring and thresholding and automation engine, and it is a management and governance kind of tool. And you'll see all of that here in a little bit. In general, our kind of biggest, brightest lighthouse customers tend to see some pretty substantial improvements in KPIs for how their models are doing, whether it's getting models into production faster, right? Accelerating model operationalization. So that's, taking advantage of things like automation and intelligent automation, knowing to take the right file, put it here, in this file there, and so forth, and being able to, remove dead time from processes, as well as better identifying the life cycle of a model, right? So just because you have a model and just because you've always done something like checked it for accuracy once a month or once a quarter or once a year, just because you've always done it that way isn't a good reason to continue doing it that way. So, when you have the ability to define life cycles specific to a model that are on path specific to that model, you're able to generate much more tailored life cycles that are better. They check things more accurately, more proactively, those types of things. And then, lastly, if I'm putting models into prod faster, I'm making sure they're more accurate and they're less risky. Ultimately, my model revenue, does go up, and we do have a very clean line of sight to things like revenue uplifts and incremental revenue gained with some of those more business impacting models, right? You're not going to see that with potentially some back office model doing HR or insider trading, but you might see that with models that are doing account segmentation or recommendations and things like that. So if we look at the ecosystem of what and how modeling and AI is coming to be in our customer base as well as in the market in general, ModelOp Center tends to sit at as a platform or centerpiece connecting the data scientists or the quants and their model factories and platforms to the production use cases. And what I mean by that is we generally are able to handle and manage the complete automation of of validation and approval processes and testing and all of that, and deployment and promotion across your ecosystem and your environment, and then ultimately deliver that model into production, and then continue to monitor and manage and maintain that model throughout its production life. To do that, ModelOp Center has to integrate to a lot of things. That is a known thing going, we knew that going in. So, the good news is everything you see on the screen here, we already kind of connect to and can import from or reach out to or talk to or offer a plugin for. So if my data scientists are using Jupyter notebooks to build their models, and then they push those out to GitHub for packaging and deployment, ModelOp Center can import directly from GitHub, pull that Jupyter notebook in, understand it, classify it, categorize it, recognize which parts are which pieces of the repo are which, and then act accordingly. And you'll see all that in the demo here going forward. Likewise, to do that job, we have to cross into a lot of other realms, right? So to be able to run a validation test, we need to know where and get access to data. So we're going to cross into the data ops and the data, kind of the data world. So being able to reach out and collect all the appropriate information from those sources and storing things like pointers is very important. Jenkins is another very common integration we see. ModelOp Center's automation engine can do deployments, but 90% of the time you've already got a Jenkins or some other code pipeline that's able to do it instead. At which point, you don't have to reinvent the wheel if you don't want to. A lot of times your Jenkins deployment is going to be doing things like reaching out to SonarQube or Veracode, or doing Claire scans or other types of security scans on your containers and all that other stuff. Great. Let it keep doing that. ModelOp Center can trigger Jenkins at the appropriate time so that your models get to deployment and get deployed into prod only when all of their documentation, only when all of their approvals are met, and those types of things. Again, in the banking and insurance world, which is where we largely serve our customers, it's a bit of a misnomer thinking that models you're doing things like auto ML and pushing models into prod multiple times a day and doing all these retrainings. Most of our customers in the Fortune 1000, it can take them 3 weeks to 6 months to deploy a model into prod, just based on all the approval processes that it takes. So if we talk about how we're able to have all these integrations and everything, it's pretty straightforward in that there's a nice little typo I'll call myself out on my slide there. Our application is microservices by design. The green ones here in the middle are what we provide. The gray ones are required. And we also provide, out of the box Mongo, MinIO, and Postgres containers if need be. All of that sits inside of your container runtime of choice. We do follow all Kubernetes best practices and Docker best practices. So we prefer to install into flavors of Kubernetes, whether that's Rancher or OpenShift or EKS, AKS, et cetera. But we also have customers using Nomad and so forth. Again, we also, every customer already has some sort of change control process in place. We integrate to that. All of our customers already have tremendous data layers and data stacks and technologies and pipelines and so forth. Great, we'll connect to that. And, I've yet to see a customer that isn't aspiring to or in process of moving to a cloud. Again, great. Depending on how you want to do it, overall where we put the product may vary. ModelOp Center is not a SaaS. It is a on-prem, exists inside of your firewall tool. So that's how we're able to solve a lot of data and intellectual property concerns. Again, just from the factory side and the model creation side, ModelOp Center tends to sit post-creation. So when models go into ModelOp Center, it's usually after they've had their hyperparameters tuned. It's usually after they've been deemed worthy, if you will. So if you're using a dev tool or workbench like a Jupyter Notebook or RStudio, we have plugins that allow you to push directly from that into ModelOp Center. For other frameworks and factories, we just import either exported versions or directly from a Git repo. Or for a lot of your more cloud services like SageMaker, we just go directly to SageMaker and import accordingly. And then again, lastly, once it goes to putting that model in use, whether that is going to be a model oriented around batch jobs that's going to sit on the proverbial shelf for 23 hours out of the day until it's time to run, or it's going to be a model that's put into hosted at an endpoint and serves via REST or Kafka or streaming, et cetera, all perfectly fine. Or if it's just a model that is actually part of a chain of models, an ensemble model, if you will, where maybe your first model is a data preprocessor or feature engineering that feeds into a second model that actually makes a decision. All of those processes, all of those options, again, fully supported out of the box. So that's all the slides I wanted to kind of use to set the foundation and framework for what ModelOp Center is. And if we switch over to the product here, Again, hopefully we can see my screen okay. This is ModelOp Center. So we're looking at our inventory right now. You can see on the left are my various domains, if you will. I've got my MLC, that's model lifecycle. Click into there very quickly. This is a live look at all the different sub-processes that are currently configured in this environment. So things like running tests, things like deploying models and creating notifications, et cetera. If I look at my runtimes, these are all the different model runtimes that we see in the environment currently. So again, ModelOp Center does have a runtime that you can use for your purposes. Out of the box, we use it for things like monitoring and diagnostic tests, validation tests, those types of things. But we do, again, a lot of our customers will use it for their actual production models as well. You can also see we're reaching out, and I've got a SageMaker model running. Jobs is exactly what it sounds like. It's just a place I can come and see all the jobs that I've run in my environment and so forth. So that said, if we start here at the inventory and we look at what we've got, I want to call your attention to a few areas. First off, you're looking at a lot of models from different languages and different platforms, right? So yes, in the AI/ML world, a large majority is certainly Python or Python 3 or Jupyter, those types of things. But there are some R and there is some C, and you do every now and then see a dinosaur of PFA, or maybe you've got a model that you built in SAS that you want to export into another tool, and you're doing that via PMML. All of those pieces are completely supported. All those different languages, fully supported, platforms, fully supported. We're able to do that because of our abstraction layer. So the way we view a model is heavily abstracted. And if I actually, rather than clicking into one of these existing ones, let's create a brand new one. I mentioned that we have that direct integration where we'll just pull a Git repo. Let's do that. And instead of pulling the master branch, I'm going to pull an extended schema branch. And I'll explain why. You'll see why we want that specific branch potentially much later in the demo if we have some questions there. And if I go to view model, what ModelOp Center has just done is gone through and started a record for this model. So I've gone through and I've collected all of my different abstractions on the left here. So if I go into source, here's my model source code. Nothing special. You're happy to, you can go in and investigate it as needed. Schemas, these are really the first example of those abstractions that we leverage, right? So this is how we tell ModelOp Center what the inputs and outputs for this particular model are. And that's how we're able to then monitor and understand things like data drift or concept drift. So we're able to see that this model has these different input features, and these are, this number of existing credits is a number, and it is used as a predictor, whereas ID is just used as an identifier. Things like gender, all right? So gender we know is both a protected class. We're also using it as a predictor here. It's, this is where we're able to start to look at things like bias and understand, hey, wait a minute, is this model starting to show signs of bias, those types of things. Same on the output, right? Again, just here's my outputs. All of this, if I wanted to edit or change, I can just add a row, call it demo table row. We'll make it a float, and away we go. Very, very straightforward, easy to edit, easy to maintain. All of that is powered using industry standard file typing and practices known as BPMN and Avro schemas and DMN, decision model notation. So those are all common in the business world and are just easy ways of defining how all of that information in a file. So what actually happened is ModelOps Center went out and cloned this repo and saw input schema.avsc. Again, that's an Avro schema. And if I click into it, and you can see it's just JSON. Here's that ID, here's its various pieces, and so forth. And we understand that that file is a input schema asset. The next place I'll bring us to is that assets section. This is where we really start to show differences between how ModelOps Center views a model as opposed to how other tools and other point solutions in this ecosystem of MLOps see models, right? We look at it as a model as a open-ended set of source files, input-output schemas, platform requirements, versions, and assets. Those assets can be anything from model source code all the way through to pickle files or documentation or test data and so forth. Our automation engine then picks up and uses those files as necessary, depending on what it's trying to do. So 6 months from now, when we go to run an automated data drift test against this model to detect data drift for it, what we're actually going to see is, hey, wait a minute. ModelOps Center is going to look and get the training data, the original training data from its records. And then it's going to use the pointer to the current data set. So whether that's following a file pointer to a bucket or running a query into a database or grabbing a set of data out of Hadoop or Snowflake or what have you, we'll collect all that data on the fly and then run those tests accordingly. So all of that gets brought in automatically. And then, just to kind of give you an idea, these are all the different types of classifications that we have out of the box, and you can extend this if need be. So this sample.json right now, it's marked as test data. I'm not going to need it for the demo, so I'm just going to mark it as unknown. It's an easy way of saying don't use it for anything. And just like that, we've got a model. So ModelOps Center uses snapshots as point-in-time versions for models and deploying them and managing them. So if we go to create a new snapshot here, what this is going to ask, actually, I skipped a step. We need to tell ModelOps Center a little bit about this model's lifecycle. So we'll do that using tags. So the first tag I want to do is a JIRA tag. That's just going to tell ModelOps Center to open a JIRA ticket for approval. Then we're going to add a demo fin and a env prod tags. And we're going to click update. So these tags are, in ModelOps Center, we use tags for two things, right? So first, we'll change this name to just demo model. I don't know why it was US Bank there. Tags are used both for organization and kind of categorizing things, same as you would in AWS or any other cloud tool, as well as defining, again, all the different metadata that a model, that a system will use to see that model and make decisions about it. So env prod, that tells ModelOps Center that we're going to put this on our prod runtime once we deploy it. That JIRA tag, again, says, hey, you need to run a test and get a JIRA approval. Demo fin is more of a just category, so I can report on it easier. From there, we're going to build a snapshot, and we're just going to, again, tell ModelOps Center some basic information about this model. It's going to run on one of our ModelOp runtimes. In your environment, you might have a model that runs in Spark. You might have a model that runs on SageMaker. You might have a model that runs on R or Java, what have you. All of them. You would tell ModelOps Center that here. Again, that's partially so that we have that record, and also partially so that the system knows, hey, if it needs to run the model, here's how. Associations, we're not going to touch here for this part, but this is, again, if I wanted to have an input model or an output model and start chaining models together to create an ensemble. And we're just going to click submit. So what we've just done is created a snapshot. This is a point in time, immutable version, copy, reporting instance, whatever you need to call it, whatever you want to call it, of this model that now is being managed. So I can come here and I can see that we've already run one job. That's that validation job that is going to need the JIRA approval. And if I hit refresh here, you can see that we've run the test. Here's the test result. More importantly, I'm going to come down here, and sure enough, our automation engine has started to do things. And here's where we're building out that image, that 360 view of our model. I can zoom in and I can see, hey, wait a minute. The automation engine said we built that snapshot. Well, is it a specific class of model? No. Is it a SageMaker model? No. Does the model need training? Well, that's an interesting question. How does ModelOp Center know if this model needs training? Well, we look for the existence of a weights file. If we see a weights file, then we say, no, it doesn't need to be trained. It's already trained. If it doesn't have a weights file, grab the training data, find the training function, run it. Okay, model requires test. That's where we looked for that JIRA tag. Yes, it does. All right, so let's build the test. We're going to grab that test data. We're going to run our test. Once the test is complete, I can see that that test was completed at that specific time. I'm going to come through and we're going to open our JIRA ticket. And now our model is effectively waiting for an approval. In some customers, that could be a one-step approval where it's just someone else validating, yes, the model works. It could be a much deeper validation process, like a second line approval in banking for SR 11.7. It could be a peer review, whatever process it may be. For us, it's just one little approval. So here we go. Sure enough, model is waiting for approval. So the important thing to point out here is we're not in ModelOp Center. We've reached out to an existing service, to JIRA, and opened the ticket. So whether you're a JIRA shop or a ServiceNow shop or a Remedy shop, don't reinvent the wheel. Use your existing change process, your existing change controls that are already in place to manage your approvals and things like that, if you want. So before we approve it, let's play the role of that second line approver, that MRM validator, that SR 11.7 validator. I want to go through and I want to make sure this model is accurate, is performant, is ethically fair, and all that kind of stuff. So how do I do that before I approve this model? Well, those are monitoring functions. So let's add some monitors. Well, the first monitor we want to add is performance for regression. So we're going to add, actually no, let's do a classification performance monitor. So just to be clear, ModelOp Center out of the box offers 24 different monitors that we can run against any model because we're looking at the input and the output of that model. We don't need to actually trigger the model itself to run these. So the first few that you see on this list are kind of the more often used, but if I were to start going through, you can see I can get into some very specific details around volumetrics. And if I start getting into data drift, I have an option of, well, which specific type of data drift or algorithm do I want to use? Am I looking at ES versus JS, or Kullback-Leibler is a fairly new one or not new, but new to me, that I've started messing with more and more. And down the, continuing on. So for the sake of basic performance, we'll do a performance monitor for a classification model. And next thing we need to do is tell it all right, it needs to know the data to run the performance test. So based on the assets already in this model, we're going to give it data. It needs sample data. So I'm going to give it this sample file. Again, for demo purposes, I'm using all data files. In the real world, you're going to be doing things like using SQL queries or URIs that point out to HDFS or S3 and so forth, or Snowflake and all of that. So now that I've told it, use this sample data, we're going to hit next. Thresholds we'll work with later. Schedules we'll work with later, and we're going to click save. So now that I've connected a monitor, I'm going to click run now. And what ModelOp Center is actually doing now is reaching out to this model and running a performance test on it. And I can see that my performance test has run. If I go to my job log, I can see here's the model I ran, I tested, here's the snapshot that was used for it, here's my input file. If I want to see my output, all I have to do is click. I can see the platform it ran on, all of that information, and then here's the logs for that job. This was a very fast job. It took an amazing 2 seconds, but if it was a job that took minutes or hours, again, you can see all of this live as the job is going through. And if I come back one screen and we look at that specific result, now we're looking at test results, right? And I can see, okay, this model is pretty accurate, decent precision and recall. My F1, I'd like to be a little higher. My confusion matrix is fine. Well, that's promising. Let's keep testing. Let's keep validating. What else do we want to know about this model? All right, well, let's test bias. Okay, so this is an important one. We're doing, again, this demonstration model is going to be doing credit scoring, so we want to make sure it's not biased. So to do that, again, we need sample data. So we're going to add that same sampled scored data file. And we're going to click next. This time, let's add a schedule. Ethical bias is definitely something that's dangerous. So we'll call this weekly ethical fairness check. We'll just name this ML fairness. We're going to run this weekly every Wednesday at noon. All right, and save. So sure enough, every Wednesday at noon, we're going to run that test, but that doesn't help us right now in validating. So we're going to go ahead and run it right now, ad hoc. And again, these tests are very quick. Took 2 seconds because we're dealing with small data files. If I go back and we now look and see our third test result, here's some ethics information. So now I'm very easily taking the information about this model, the data files that we know about for this model, and now I'm doing governance work. I'm making decisions. I'm validating that this model is effective. Well, it's got some bias concerns, but for the sake of demonstration, let's just say it's okay. And I can start to see comparisons. And again, there's certainly some things that are alarming, but we'll say it's fine. So let's now deploy it and approve it. But first, before we approve it, let's set up one more monitor. So this time I want to do some stability data, some data drift monitoring using PSI. So we're going to do, this time we know we need baseline data. So again, for demo purposes, I'm just making sure it's all here and easy to use. But in the real world, you're going to be reaching out to other tools. And we're going to do that. But data drift is an interesting one because there's, I do care about it, right? It is something that I want to make sure stays within an existing bound. So I'm going to use a threshold file. So this German credit PSI file that we're going to upload. And again, we're going to run this, instead of Wednesdays, let's run it every Monday, again at noon, because, why not? Real men test at noon. We'll call this CSI data drift, stability drift, drift. These are schedule name and signal name are placeholders for if you have lots of different monitors and monitoring schedules with different data sets and things like that. And we're going to click save. So just like that, I've enabled PSI CSI monitoring, stability monitoring for data drift on this model. We're going to go ahead and run it here in a second anyway. But what we can do is now come back to my workflow, my Jira ticket, mark it done. Hopefully I didn't log out. Do a hard refresh. I did log out, of course. All right, we will take this, mark it done. And if we now come down to the bottom, so a couple things to note, each of those tests, the information has been stored. We're building that audit trail, that forensic history. I'm giving it a second killing time purposely to let it deploy here. But while I'm doing that, everything we've done so far, again, because of that best practice microservices design philosophy that we started with, everything we've done in this UI can be done through APIs, can be done through CLI. It's all, easy REST calls, etc. So sure enough, I can see now that my approval was received at this specific time, and then we, sure enough, deployed that model out to a runtime. And if I scroll up to the top, you can see currently Engine 1 is serving this model. So what does that mean? That means that if I click on Engine 1 here, I can now interact with this model in real time through REST. So we are accessing I have access to a REST endpoint. Here's that URL that I could then provide to my downstream process or my UI or another service or something else, and you can get inferences from this model. It's effectively deployed. If I come back to my runtimes, sure enough, I can see demo model is now deployed on prod 1. So if we come back to our model and, again, it's deployed. Congratulations, we've achieved the hard part. We now have our model in production. It's doing things for the business. We're getting pats on the back. Look how great we are. We're awesome. Let's, for sake of the story here, let's fast forward maybe a week or two, and we want to start checking for things like data drift. We're going to just go ahead and click run now. And sure enough, we're going to run it. And it's going to complete pretty quick here because we're just not dealing with a lot, or it'll error. Let's see what the error was. Score does not exist in the data frame. So what happened here is ModelOps Center tried to run a PS, run the test, and we gave it bad data. So let's come back to our model, and we'll go back to our snapshot. Let's edit this and give it the right data. So we know that our baseline, again, just quickly search and find it. Use sample scored this time. So that was not part of the demo. That was just me being fat fingered. We'll upload that same DMN file. Don't worry, we'll look at what a DMN file is here in just a second. And we'll run it again. So while the system is doing the things, we'll do a hard refresh. Yep, sure enough, it's a 2-second job. Joys of demo data sets. I can see my logs, everything else. If I come back one screen and we look at our test results, here we are looking at stability indexes. So I can see, for each of my PSI, my chi-square, and my KS for all of these different values. And if I were a data scientist, which I am not, this would all make sense to me and I would be able to make a decision. But I'm not a data scientist. I'm a sales engineer. And that generally means I'm not super smart when it comes to what I'm looking at here, and I certainly don't know if this big area here is good or not. So if I just go back to my dashboard and we click refresh, somewhere in here, this is where technology rarely behaves as expected. I'll do a hard refresh. But somewhere in here, I'll be able to see that eventually ModelOp Center will determine that that test passed and that we're in good shape, or that it failed. The way it's going to determine whether or not the test passes or not is we're going to look at the raw results of the data. So our monitors, our out-of-the-box monitors, they provide all of these metrics based on those schema files. And we can then decision on any one of them. So if I were to go now, we'll do kind of a side-by-side here and look at our decisioning here. On the right here, this is a DMN file. So I'm using Camunda Modeler. It's a open source, kind of well-used DMN editor. Think of it like the VS Code for DMN world. But most shops, DMN is just it's just tables that you export. So it's basically XML underneath all the covers. So you can actually export from Excel or Project or Visio and so forth if need be, or you can use any of the online editors, or again, in a lot of shops they'll have again, using the VS Code and IntelliJ analogy, they'll have Camunda Modeler for the open source people, and then they'll have things like Pega for the closed source world. But all I have to do is say, for this variable, credit history CSI, I want it to be greater than 0.01. And if it's greater than 0.01, I want to fail my test with this reason. So looking at those two things, we should see then ModelOp Center will eventually fail this test result because 0.0102 is over 0.01. If I wanted to add a new rule, let's say add a new, let's say we want to now look at installment plans CSI. All I do is copy the output, paste it there. This is going to be everything else is doubles, so we'll make this a double as well. And we'll set a rule for it, greater than or equal to, I don't know, it's 0.00, so let's just say 0.0034, something like that. We want it to, instead of fail, we want it to pass. And just like that, we've created a threshold. The reason why we choose to use DMN files and the DMN standard for thresholding is because of a couple reasons. First off, if you think about our counterparts in the line of business, DMN was originally built and created by the insurance industry as a way of modeling and underwriting and doing these types of things and being able to model a decision. The M in it's decision model notation, DMN. So it's a very natural fit. And and you see the value of that in how open-ended it is, right? So this is a collection policy. It's going to look at and test each of these rules and collect all the trues and falses. I can change it to a first policy where I'm going to go through and look at which is the first rule that it hits, that it comes true on. So I can start to really have some very granular control over things like thresholds and ranges. The second reason why we use this is it's file-based, right? Everything you've seen me do so far, you haven't seen me enter in any of these values, right? That DMN file was originally in our Git repo. Actually, it was originally on my computer here, but you saw me upload the file. I could have just as easily come here to my model and uploaded the file here. And then come down to the bottom where my list is and mark it as, oh, it knows it's a test result comparator. So I have the ability to do all of this without human intervention is where I'm going from this, is all of this can be done through APIs, through automation, and it's designed that way. So if I wanted all of this to trigger off of Jupyter Notebook, great, no problem. If I wanted all of this to happen based on a commit into my repo, great, no problem. Part of importing from ModelOps, from that Git repo, is that ModelOps Center will now check every 2 seconds, or every 2 minutes, excuse me, by default, back and look for, is there a newer commit version? Is there a newer, is there new code to bring in? And it'll bring that in. And we can then start this whole process again. So that gives us a lot of flexibility and a lot of power in terms of what kinds of tests we want to run, what kinds of decisions we want to make, and what kinds of things we want to do. If we take all of that and put it together, it takes us to a pretty interesting perspective, which is, if I look at this version of a model, in just the last, call it 30 minutes, we imported a model from a repo. We deployed it to a runtime. We ran a number of tests on it. We were able to make intelligent, informed decisions about that. We were approved the ticket so that it was further deployed. And we've gotten notifications that it's being run and things are happening and that the jobs are being ran. I can come here and I can come down and I can see here are my problem children. So I have notifications on all the failed tests and all the errors and things like that. That's really kind of the end-to-end life cycle here, right? We just did what a lot of shops take months and months to do, of taking a model that's already built and ready, running it through a validation process with both human and automated validation, deploying it onto a runtime that we can now inference against, and having all of that at my fingertips for audit purposes. Right? So if I were to, take this and here I am going probably a little deeper into the sausage making than one might want. But if I swap this over from our UI to our API, here's all of that same information in flat JSON. I love handing this, all of those test results, all of the steps, all of the durations, all the timestamps, all of the validation results, all of that. I love handing this to risk management, to auditors, to validators, because it's so much information right there of just, hey, here's everything you need. Here's all of the schema for the inputs. Here's how it's expected to output. Here's the source code it's using. If you have documentation, we can even read that documentation into this so that you have that kind of single push it here and away, here you go. So, right, what else is missing from this or what else is missing from our life cycle? Right, we've decided the model is ready. We've deployed the model. And if I let this thing sit for the next week, we'll show that we're automatically testing it and monitoring it. Well, let's just kind of run this test a couple more times just to start and again build a story. I'm quite literally just going to run the same test a couple times. And the reason I'm going to do that is because 6-7 months from now, there's a good chance the person who's going to have to decide whether or not this is a good model, this is a valid model, or it needs to be pulled, whether or not my challenger is better than this champion, has no idea what what I did or what was. So he's going to want to do things and look at things like trend lines. So if I come to my monitoring here, and I've only run one. Okay, so let's run some more performance tests. Again, this is me going too fast. And then we'll run some more eyes. Well, again, I'm just trying to build a library of test results here and show that we've got, yeah, they're chewing through. So now if I come back to my model, and we go to our specific version, and come to my monitoring, and now I've got trend lines, and I've got historical views. And we can start to see, if I was doing data drift detection, my p-values over time, my CSI values over time, all of that information put on trend lines. Fun fact, if you use the same data, you get a straight line. So that's why it looks like this. But if we were to use different data sets, we would see that change. Now, not only have I gotten my model into prod very quickly, so speaking myopically to an MLOps and deployment perspective, I've done a deployment in an automated fashion. Great. But I've done more than that. I've done an intelligent deployment. I've made a validation and determined, yes, this model is ready for production. On top of that, now I'm starting to monitor this thing over time. Hey, my precision is starting to degrade over time. Let's go and ask data science to build me a new challenger for this model. Or, if it's a fraud detection model for transaction fraud detection, and COVID hit, maybe the model is no longer accurate. Maybe some world event has caused massive data drift. And what used to be a very powerful predictor is now no longer. That's exactly what all the banks saw with card present as an example. So if you think about what COVID did to a lot of models in banking, card present was a feature that a lot of fraud detection models relied heavily on, because that indicated whether or not the person was present with the card to make that transaction or was online. My 87-year-old grandfather does not buy things online. Card always present. What did he do when COVID hit? Started buying things online. Card not present. Immediate fraud notifications. His card got shut off half an hour after his first purchase. He was not very happy. That's an example of, major data drift causing issues. So how does the business resolve that? They go out and they commission a new model, a challenger. So let's go ahead and say that something has changed and now we're going to have a challenger model. In ModelOp Center, all that means is creating a new snapshot. So we'll call this our challenger snapshot. We start the process again. This whole wizard in the human GUI, it's a wizard. In the REST API, it's a post. Let's add, instead of classification, let's do a regression performance. I don't know why I would do that differently, but just for the sake of showing you visualizations, let's. We're not going to schedule this. We're going to click save. We're going to run that now. And here we are comparing apples and oranges, a classification versus a regression. So I should have thought about that before I did it. So let's add another one, and we'll do classification. The reason you are seeing this snapshot ask here is because these models, these monitors, are out-of-the-box models we provide. So we're going to go ahead and trigger that. But now if I come back to my home screen, and we look at my models, and I switch to my monitors, if you're wondering, well, how are you detecting? How are you calculating all these things? Well, here's exactly how. Right? So that that classification model that we just ran is quite literally this. Here is the model. Another really cool thing, say I wanted to add my own model. A lot of shops will create their own metrics or their own features that they want to monitor performance against. Go for it. All you have to do is import a model as a monitor. Simple as that. So if we come back to, sorry, I'm clicking so much here. If we come back to our demo model, now we've got two different snapshots. And the snapshot, sure enough, there's our classification. And here's our regression, nice and straightforward. But how do I compare them, right? So let's compare some snapshots. Oh, I clicked too fast. We'll give this a second to load. And here we are comparing our different snapshots. So you can see I've got a lot of tests here that need some filtering, but what I'm doing is looking at, sure enough, here is not a great example because we're comparing different types of tests. But this is where the comparisons come. So now you can start to build yourself a visual of, here's the overtime comparisons, or here's the side-by-side comparisons of F1 scores or F2 scores, etc. And you're able to get all of that information and make these informed decisions. But more importantly, you're able to come here and design those decisions, store those decisions as a file, and upload them. And ModelOp Center will babysit your model, so you don't have to. So we're about an hour into the 90 minutes. If I were to pause here and first look and see if there's any chat questions and such. I see this Malik guy just came in and said some stuff. I've got, all right, cool. That's not a poll from me. All right, so if anyone has any questions, go ahead and pop them in chat. Otherwise, we can keep going. This hop-in thing is pretty cool. All right. So what I can do then is, now that I have a decision modeled as a file, and I have a model, and it has all of its information and all of its metadata, I can automate that process. And I can come to my MLCs and I can start to build automated processes that run every so often, check, validate that a model is this, that a model is that. I don't want to get too much into the building of these processes because Jim Olson, our CTO, is going to be doing a session, I believe, later this week on that exact topic, and I don't want to steal his thunder. But these are, if we zoom in and see, here's what's going on. All right, that's not a good one. If we look at that same deployment process and we see, here's the steps that it goes through. Here's how it works. Here's where it makes the decisions it does. This step right here is where we are looking at the test results and comparing them to that DMN file and doing that automated test. So that ticket that we approved earlier only was created after our automated tests. So, governance out of the box, kind of important, especially if we're dealing with, models that are important for something or impacting the business. I like to think back. I was privy to a customer. One of our customers was having a conversation internally, the conversation started off with us doing a presentation, and it squirreled off into an internal one, where they had a data scientist saying, well, I want to use AutoML. I want to have 10 new versions of this weights file every hour. I want this, I want that. I want all these bells and whistles. And the head of data analytics just looked at it, just said to him, that's not how this insurance company does modeling. That's not how we do analytics. Governance is important. Making sure that these models are ethically fair, are documented. You see the same in banks with things like MRM, model risk management, and SR 11.7. The EU is starting to do the same with the same organization that came out with GDPR has now started producing content around what ethical AI and decision modeling is going to look like. All of that is going in that direction. So as much as we want to love the idea of doing hyperparameter tuning constantly and automated training and retraining and having AutoML and all these other types of capabilities and allowing the machines to build machines and build machines, Skynet's pretty far off. The world we live in today, the industry that we live in today, the market that we have today is still very much governance driven, risk mitigation driven. And what you've seen is a platform that allows me to take any model, regardless of language, regardless of platform, regardless of runtime, regardless of business unit, regardless of data consumption, regardless of inferencing style, whether it's batch or online, REST or Kafka, streaming, whether it's natural language processing or image recognition or credit scoring, sentiment analysis, whatever model you've got, bring it into a platform and govern it effectively. But more importantly, govern it automatically and monitor it continuously and over time. So hopefully somewhere in there was some useful information. Again, my name's Matt Laster. I'm a senior sales engineer here with ModelOp. On the chat, I'm going to put this on another window so I can watch it.